Hi, good day. Today we are going to look at testing in Go. And as usual, we will look at a C# program and convert that into Go. So on the right, I got a simple interface and I got an implementation to the interface. So it's an iCalculator interface and we're going to implement the four main operations on it with integers. And to do that in C#, you would have your main library in a project, so that wouldn't have any test aspects to it. And so that's the max project, and then in your max test project you would create your tests. So in this case we are going to use xunit as our testing library, and we will write our tests in this library. So we'll have, for each one of those methods in that interface, we will we'll write our tests. So to run it, we would basically say, let's first run the project itself. So we're cd max, and our max method takes the arguments in the command line, and it's going to call the methods of the calculator. So it takes two arguments from the command line and it basically calls add, subtract, multiply, and divide. And so let's do that. So you say .NET run and two numbers, 10 and 2, and that should give us these. So it basically, all the four operations is written on the console. And to run that, we have to go to the test project. So to do that, let's create another terminal, cd max test, and this is the test project, and to run it we'll say .NET test, and that should test all the four methods, and all the four tests are passing. So I'm not going to go, as usual, I'm not going to go into too much of a detail walking over the C# code. If you want to have a look at it, head over to my GitHub repo, and uh, you should find the full source code there. So let's close that, and let's minimize that, and let's look at what we have to do in Go to do this. So in my previous videos, we have pretty much been writing all our code in the main uh, in the main repo, main class itself, main.go. But in this instance, because we got we need to test, we need to write the server interface, we need to implement the interface, we will use multiple files. One of the main things of difference between testing in C# and Go is the Ghost test files are organized within the project itself. So if you want to test this particular Go file, you will have main. This is main.go. So if you had to test this, you will say main_test.go, and that file lives inside the Go package itself. The Go compiler is a bit smart, so whenever it sees the test postfix of a file name, it would automatically remove it from its final build. So that way we are able to organize the testing of the test files within the main package itself, and that solves a few issues, right? So you see, I got my interface, it's public, and the calculator is public as well. That is okay if we want it to be public. What if I wanted to test an internal class in my unit test? So to do that, you either have to do some weird things like make the class library a friend, or what people end up doing is making them public just to help with testing, which is okay, but it's probably not ideal. You would want to be able to unit test your internal objects as well, and not having to make them public would be a lot more cleaner. So because the tests in Go are going to be as part of the main package, uh, that we don't have the same problem. Okay, let's do this first. So we have an interface and we have a calculator. So as usual, to do that in Go, let's actually not do it in the main file itself. let's first do initialize our module. So to do that, go init mod. Go mod init. So what that does, it adds a module mod file for us, and then it asks us to say that becomes our module. So we can have multiple files and we can create uh, and they all hang together under the same package. So let's close it down a bit, and then let's create a new file for our calculator. Let go. Okay, so here the package will still be main. You can use different packages within the same library, but we won't go into that now. Generally, you are not going to need more than one package within the same program. Um, okay, so that's here. So let's create our interface first. So to do that, type. Okay, and another thing. So in .NET, we are used to having the I prefix with the interfaces. In Go, we don't do that. So let's call this calculator service. It's an interface, and we will define some methods. So add, it will takes two numbers, a int, b int, and returns an int. And we need to do that 4 times. So let's copy this line. So, and the method names are the only difference. Just copying them over. And so that's our interface. So to implement our interface in Go, we have to create a struct and then duck type the methods to it. So type. So let's call this calculator and struct. And we don't have any fields in the struct, so we can leave it as it is. This is just the calculator. Okay, so now we need to add some methods to the struct. So we need to say func, and we are adding it over the calculator, and we can just copy this and we define our method itself. It's going to return a plus b. Okay, that's it. So let's just copy that over a few more times and subtract. Multiply and divide. Okay, I'm just gonna leave this a plus b so we can have a failing test and then fix it. So that's pretty much our calculator service, and we implemented that. So in our main method, we can go, we will create an instance of that service, and then we'll call methods on that. So let's, in our main program, we are getting it from the command line as arguments. So let's do the same in as well here. So we first need to create two variables. To get it from the command line, we are going to use the package os.args, and you can get the args of 0 and args of 0 is going to be your program name, 1 and 2 is going to be your command line arguments. It's very similar to C#, and it's going to give us a string, so we need to convert it to integer. So we're going to use the package string dot ata2i, and that is going to return, we are going to put that in a variable, which is going to return our a, and it's also going to return an error variable. So you can actually, you can say, you can do error and check if the error is nil and do whatever you need to do, but for the sake of this sample project, we're just going to ignore the error, and that's pretty much A. So let's do the same for B, and B is going to be 2. And now we just need to create an instance of our calculator. So we can just create an instance of struct and call methods on the struct, but let's do something different. We will create an interface. So how do you do that? So interface doesn't have an implementation. To get an instance of that interface, we will say where CS and our interface, which is going to be the calculator service, and we will do a new of the calculator itself. So new calculator. So that would give us, it will use the calculator struct to give us a reference to the calculator service. Now we can call methods on this calculator service. So let's just call them. So let's say fmt.print ln. So we'll just do what we have done in the C# code. So you're going to say a comma plus. You can do a string interpolation here. So I'm just doing this as I go. If you, and then we're going to say cs.add is going to give us the, we need to pass the two variables a comma b. So that's it. So we will just need to call it a few more times. So with subtract, divide, and multiply. So this is going to be minus, division, and multiplication. So at the moment, so we have written our Go interface. We have defined the struct. We have duck typed the methods on that interface, and we are creating creating a type instance of the calculator service and calling the methods on it. So at the moment we should be able to run it. So to run it, because we have defined a module, we're going to run it. We're just going to run at the folder level. So go run and dot. So that should give us, forgot to send in the command line arguments. So let's say 10 and 2, and yeah, here you go. So as you see, these are incorrect results. So let's actually write a test to it. I have done the implementation first for the sake of this example, but if you're following TDD, you would first write your test. So to do the test, so in Go, as I mentioned before, the test live along with the package itself. So to test, so we are going to test the calculator. To test the calculator, we have to create a file in the same folder the calculator.go lives, but we're going to name it calculator underscore test.go. So this is a convention the Go compiler actually understands, and it's going to ignore them when it's building the package for releasing. So this will be, so even the package will be in the same, even the test will be in the same package as the other file. And so the first thing we need to do is import testing. I shouldn't save it because it gets rid of it if we don't use it. And to create a test in Go, create a func, we will test add first, test add, and it takes it an instance of testing.t, so it'll be t star testing.t and open close braces. So that's that is skeleton of a test. So it only takes an instance of testing of t, and then we basically call that method. So how do you call it? So we have two variables, a. Uh, so in our C# test, we basically have what let's do. So we have the a and b. So colon is 10 and b colon is 2, and our expected is 12, and we create the calc instance of the calculator. So we need to do just pretty much that. I'll copy that, and so that's our calculator service. And I'll say actual colon equals to cs dot add a comma b, and now we say if expected is not equal to actual, we can use t dot error f add was incorrect. Expected incorrect, expected let's percentage %g actual %g, and we will just pass those values, expected, actual. So here you go. And to run the test, it would be let's just do the rest of them as well, so before we run them. So let's copy that and we paste them for the 4 operations we are going to do, and we're going to do test subtract. And when we subtract, our expected result is 8. So divide. When we divide, our expected result is 5, and divide. And likewise, let's multiply. And the expected result is 20, and we're gonna multiply. Okay, here you go. So we got our test. So let's clear that. To test in Go, we're going to use the test Go test, and we're going to say -v to get us a verbose result. So let's say Go test, and it's going to run it. So it ran test had and passed. It ran test subtract, and subtract was incorrect. Divide was incorrect, and multiply was incorrect. So it expected 8 and it got 12. So let's go fix them. So subtract, I need to use the subtract. Multiply, I need to use multiply, and divide is obviously this. So now let's test again. Clear? So go test verbose. Now everything should pass. So it basically ran all the tests. If I don't give verbose, you're going to get a very succinct result back. It's basically going to say pass, and everything passed. So that's pretty much all testing in Go in a nutshell. The main differences are the tests live along with your package itself. We don't need to create a separate project for them, a separate library for them, and that gets rid of the issues like testing internal methods and things like that. So you don't really need to change your modifier just so you can test it, and it's easier to maintain. So if you have multiple folders and subfolders in Go, the test lives along with the file wherever the the file you're testing lives. So here we got calculator go, and the calculator test lives right along with it. The compiler is smart enough to ignore them when it's building the package for release. And VS Code Go thing has some nice integration for testing, so you can actually click on it and test it. This integration is even better than C Sharp. So C Sharp doesn't come with that functionality by default. You might be able to find extension to do that, but I thought that was pretty neat. Um, and what else I wanted to touch upon? Other things. So here we are. So you'll see we are not doing a kind of an assert. We are basically just doing a normal comparison. Why not? Go itself does not prescribe to do specification style asserts. If that is your preference, you can use some third-party packages which bring that functionality to you. So that's fully a personal preference for you. That's pretty much it. Thanks for watching, and please subscribe to learn more about Go from the point of view of a C# programmer. Thank you.